Welcome to Computer Metanoia. My name is Onono Shannal, and we are in the middle of the chapter of logic gates. In the previous two videos, we have seen what are the seven different logic gates that is being used to design a particular digital circuit. Other than that, we also have another logic gate which is in existence, that is a buffer. In this particular video, we will be talking about the AND gate. And so to start off with AND gate, first let us look at the truth table of AND gate. You see, we have the truth table something like this, that if x is 0, y is 0, the output is 0. X is 0, y is 1, the output is 0. X is 1, y is 0, output is 0. X is 1, y is 1, output is 1. That means if only if both the conditions are true, then only the output is coming out to be true. True means 1 basically, and false means 0. Now the symbols that we have, the boolean symbol that we use to express, is equals to x dot y. Dot symbol is used. Dot means and. We have seen it in the last couple of videos. We also use a upward arrowhead, that is also analogous to AND, or simply we write XY. We don't put this AND. And to talk about the AND gate symbol or the circuit symbol, you see, it is a D-shaped gate, something like this, a D-shaped gate with two inputs in one side and the output in another side. So basically, from this side, from the right hand side, we are actually getting the output, which is x dot y, and from the input we are getting x and y, two values, two binary values. Now talking about the laws, that some properties of AND operation, that is the AND operation is commutative. That means x dot y is equals to y dot x. Nothing to explain. In fact, it also obeys the associative law, that is x dot y dot z is same as x dot y dot z. Fine. Now the most important or interesting part of it is called uh, is that it is a very interesting, and important interview question as well. So the question is something like this. First, let me tell the solution, then um, I'll be actually telling you what the question was basically. So to understand it, first let us look at the truth table. Fine. In this truth table, we have concentrated on two sets of values. Fine. Two sets of input and output. These two sets, the set above this partition, the set above the partition below. So consider the set above this particular partition, that is these two inputs, these two values of truth table. Fine. So you see, 0 0 gives 0, 0 1 gives 0. So basically you see, I can say that x is fixed to 0. Fine. That means if I fix one particular value of this particular logic gate, that AND gate, to 0, and if I provide the input of 0 over here or 1 over here, what is going to be the output? The output is still going to be 0. For this case also it is going to be 0. That means whatever the input might be over here, if I fix this particular input pin to 0, then whatever the input I am providing over here, it will not have any effect on the output. The output will still remain 0. So basically what I have done, I have actually disabled this particular AND gate. So the question might be asked, that how will you disable a two input AND gate? So that is, whatever input you give, the output will remain 0. So how will you do it? You will actually fix a particular pin to 0, and then in the other pin that is left out with you, you provide whatever input, 0 or 1 or whatever it is, the output is still going to be 0. Because if if any one of if you see, if either one of the inputs is 0, the output remains 0. So it is basically that concept. And over here, if you look at the next two combinations, that these two combinations, here you see that x is fixed to 1. What happens is that if we fix x to 1, and if I put 0 over here, give 0 as an input, if x is fixed to 1 and we give 0 as input, what is the output? The output comes out to be 0. Again, if I fix x to be 1 and I give the input 1 over here, then the output comes out to be 1. That means if I fix this particular input, one of the input to be 1, and I provide and whatever input I might provide to the other left out pin, that will be straight away reflected in the output. And this is the property of a buffer. That means if we are asked to use an AND gate as a buffer, you will be saying that we will have to fix one particular pin to 1, and we will be providing our input in the left out pin, and whatever input we give in that left out pin will straight away come out as output. So that is how you use a AND gate as a buffer. This is a very important interview question. And now another important interview question is something like this, that you have a two input AND gate. Fine, you have a two input AND gate, you have inputs x and y. What are you going to get in the output? You're going to get x dot y as the output. Now you have a three input AND gate with you, and you have to use it in such a way that it acts as a two input AND gate. Fine, you have to use it as a two input AND gate. Now clearly we will have one unused input, because we will be using it as a um, what should I say? We will be using it as a uh, uh, two input AND gate. So for two input AND gate, I'll be using up two of these inputs, and the other input will be left out. That will be unused input. So what should I use this unused, means how should I connect this unused input so that I still get the desired result of f is equals to x dot y? Now there are basically two approaches. That is, if I make z equals to 1, if I make z equals to 1, that means 1 dot anything. See, 1 dot anything is that self. And 1 dot 0 is 0, 1 dot 1 is 1. So 1 with 1, if you AND anything, you are going to get that thing itself. So basically, if you dot AND over here, so 1 dot anything, 1 dot anything returns you that thing itself. So basically, if you connect this z to a high voltage, that is to 1, you are still, and you provide the respective inputs for x and y, you are gonna get the desired result of x dot y. That means you can use this three input AND gate as a two input AND gate if you connect the unused input to high voltage. The other way of doing it is, you can connect this unused input to either of the two rest of the inputs that is there with you. That means, suppose you have x dot y and you connect z with y. That means z will become y, so it becomes y. Now y dot y is y. Fine. How do I say that? See, 0 dot 0 is 0, 1 dot 1 is 1. That means same things will give you the same thing. That means two same things ANDed will give you the same thing. Two same things ANDed will give you the same thing. Two same things ANDed will give you the same thing. The same thing takes place over here. Y dot y will give you y, and you are left with x, so x dot y. So if you connect this particular unused input to either of these two inputs, for in this case I have connected it to y, I can use it as a two input AND gate. Now the best method is to connect the third unused input to 1. This is the best method. You can even use this method as well, but this is the best practice. I don't know why, but it's the best practice. So that's all for from AND gate. In the next video, we are going to talk about the OR gate. So stay tuned and please watch the next videos. Thank you for watching.